Okay, so now we're talking about ECL arithmetic. Most of this is very basic. In fact, it's incredibly basic in terms of what you've seen in other programming languages, such as Java, Python, pretty much anything that is a current day programming language. It has the same. There are a few differences, and I'll denote those right here, and I'll show you how that works within the code. But for instance, you have multiplication, you have division, you have integer division, which is what we're going to talk about here in a second. Then they also have modulus division, as well as subtraction and addition. So all of those are pretty standard, except when you start talking about division. Now, so division in ECL is actually done a little differently, and they did this because there's this particular cases where you're going to want to have to get rid of all the decimal points and just keep the whole number, or you're also going to want to keep the decimal points. And they did this by making something called integer division. So I want to explain how that works here. I have my ECL watch and my ECL playground running, and I have defined two variables, x and y, to x to 450 and y to 2.15. Now I have two variables getting results from those. I have non-int z, which equals x divided by y, and then I have int z, which equals x divided integer division by y. So let me explain the differences again. When you're using this slash mark, that's actually referring to non-integer division. And what that's going to give you is all the decimal points that go along with making this mathematical deduction. Now, when you put something like x div y, that's integer division. That's going to go ahead and shave off all those extra decimals for you. So let's go ahead and run this, and I can show you what the outputs look like. So if you watched a video before about how things are returned in ECL, you will understand why it's being returned like this. But I have right here int z being returned, and int z, of course, is the integer division. It only equals 2. Now 4.50 divided by 2.15 does not equal 2, but it does, however, equal 2 point something. Now let's show you what that point something is right here. This, of course, is the regular division, which does not shave off the decimals. So we have 2.093, etc. And this is just a good example of the different mathematical properties of division. Now there is one more special case in division that is an integral piece of ECL. They didn't want dividing by 0 to throw the whole program off. This was something that when they found when they were running the programs, that if they encountered a divide by 0, it would stop the whole operation. And ECL is usually used to run huge operations. And if you walk away, and then you lose a lot of time because the program stops. So they decided to add something called the divide by 0 option. We'll get into what the hashtag option does, but just as a quick preview, it allows you to change the ways ECL handles certain items. And this item would be the divide by 0 item. So there's 3 different options you can place here. And let's go ahead and just make this y equal 0. And we'll just go ahead and return x divided by y, and that would be int z. So we all know what that should equal. That should equal this 2.093. Oh, I'm sorry. If it was 2.15, it would equal 2.093. But 4.50 divided by 0, that's impossible. We can't do that. That would generally create an error in the program. Let's see what we do here. So in the option, I'm going to change this parameter right here using these options. Now I have 0, fail, and non. Now 0 will just evaluate to 0. So let's go ahead and run that and see what we get. So you see here our result is 0. If we change that to fail, and by the way, the default is evaluated to 0. So if you don't tell it to fail, by default it just won't. It'll just make it equal to 0, which could be misleading, which is why they allow you to do this. So if we do a fail, it's going to generate an error. Or rather, it's not going to do anything at all. There will be no return. So the program stops when it gets to that point. If we do a non, it's going to return a non-value. And non is similar to something like not a real number, etc., etc. It's just a placeholder to let you know that there was a divide by 0 issue there. So again, that's ECL and how it deals with division. This is how ECL deals with the divide by 0 problem. It was something that they wanted to hard code into the program, and that's what we have here.